everyone and welcome. I am Srushti Kulkarni and in this video I will explain the simple code generator. As we studied various stages in a compiler such that lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, and now we are on a final stage, that is a code generator, that means machine level instruction. So let's start with that. uh, the basic code generation. This phase of a compiler convert the intermediate code into the machine level instruction. Our approach to focus on a three technique. First one is a single basic block. In that we generate a code for one block at a time using three address code. Suppose we have an expression a is equals to b plus c into d. We convert this into three address format. So we know that in three address format we firstly check the which operator have a highest precedence. So that is simplified first. In that multiplication have a highest priority, so we simplify first. We take a temporary variable to store the multiplication result. So t1 is equals to c into d. Then we give second temporary variable which store the b plus t1, and then we assign a is equals to t2. So next one is a load and store minimization. In that this reduce how often we access memory. Instead of loading and storing a variable repeatedly, we try to keep the value in a register. For example, if a t1 is already in a register, we don't load it from memory again when we use it in a next instruction. Third one is a register tracking. In that we keep a track of which register are currently used and what value is hold. If R1 register holding value of T1 and we don't overwrite it, we can reuse without reloading from memory. So next one is the uses of a register. In that there are four uses. First one is a operand for operation. To perform the arithmetic operation like x equal to y plus z, both y and z need to be in a register. Example, move r1 comma x. We assign x in a r1 register. Move r2 comma z, we move the z into r2. Then add the both r1 and r2 into the r3 register and we assign x equal to r3. Then is a temporaries. In that intermediate result like t1 or t2 in a previous example are stored in a register temporarily. Next one is a global value. In that variable that are used across multiple block like loop counter. For example, in a for loop we use I multiple times because of iterations. Next one is a runtime storage management. In that register are used to manage the stack pointer, return address and function call. So when we create a simple code generator, we need to keep in the following in mind. First one is a limited register. There are only a few register available. We need to smartly allocate that and free them. Next one is a prior code simplification. In that before generating a final code, we simplify it. For example, a is equals to b plus 0. We can be simplified to a is equals to b. This reduces the instruction count and improves the feed. Next one is a efficient operand handling. In that we need to arrange the operand to avoid the unnecessary swap. So next one is a instruction format. In a code generation, three basic instruction format are used. First one is a LD, register comma memory. Load the data from a memory into the register. Second one is a ST, memory comma register. Store the value in a register back into memory. So next one is a operator, register comma register comma register. It performs the operation like addition, subtraction using three register like R1, R2 and R3. We adds and R3 and store it into R1. There are two important descriptor. First one is a register descriptor and second one is a address descriptor. In register descriptor, this track which variable are currently stored in a which register, it being empty and update dynamically as a code is generated. Second one is a address descriptor. In that, this show where the current value of a variable is stored. It could be in a memory, that stack, or in a register. Now let's look at the benefits of using simple code generator. First one is a reduce the memory access. In that, it minimizes redundant instruction, reducing the need to load or store the data. Next one is optimizes register use. In that, efficient uses of a limited register lead to better performance. Next one is enable compiler efficiency. In that, a simple generator result in a faster compilation due to smooth code flow. Next one is simplifies the debugging. In that, clear and straightforward code generation facilitate easier debugging and maintenance. Now conclusion is, in a conclusion, simple code generation technique are such as essential in a compiler, critical tools, and optimized output. In essential in a compiler, they make compilation process more resource efficient. In critical tools, both register and address descriptor are vital to manage the value effectively. Next one is optimized output. In that, uh, focus is on minimizing resource uses and maximizing the speed. So thank you for watching.